Hello. It was going to be a challenge to fit what was originally supposed to be about a 45-minute talk into the time slot, but it's going to work out pretty easily, actually, because all the other speakers already covered like a bunch of the things, and so hopefully this will see how they fit together. So as mentioned, I work for a company called ThoughtWorks, and one of the things that we're guilty of is making up words, and we've written a few books and that kind of stuff. And a lot of times, when it's a consulting organization, it's like, well, where'd that really come from? So what I wanted to give you is a little bit of history about where some of this stuff came from, at least as from our perspective. So Act 1, United Kingdom in 2005, we're starting a project. And at the time, ThoughtWorks was, 12 years old at this point. We pretty much thought we knew everything. We had two people that signed the Agile Manifesto, Martin Fowler and Jim Highsmith both worked for us. We had written the definition of continuous integration. Again, didn't invent this stuff. People have been doing CI for decades, just didn't call it different things. But we'd written that definition and thought we were pretty good at it. We created cruise control. So whether or not you consider Tinderbox to be a continuous integration server, potentially for one of the first ones of those. We created Selenium because we were starting to do more web apps and we want to test things. So we thought we were pretty good. We go on to this project, and if you've ever written Java, you know that if you write it once, it runs anywhere, exactly the same, right? Doesn't matter the operating system, or so Sun would have us believe. Yeah. So we're on this project, and they issued the developers Windows laptops, but the deployment environment was going to be a Solaris cluster. And of course, even though we're an agile shop, procurement of the Solaris hardware wasn't scheduled for several months into the project. So they're developing away on the Windows laptops. And they did all the right continuous integration things. So they had cruise control running, and every time someone would make a commit, it would build it and running all the tests and doing all the things, and they'd get their installer, and everything was good. There was only one small issue. Turns out they had done some things, some disk caching things and other things that simply would never work on a Solaris NFS, network file system. So that's bad, right? One of the things this taught us right away is the value of a cross-functional team. So if there had been a Solaris administrator or somebody with deep Solaris experience on that team, never would have happened. Not that that person would have to become a Java developer, not that the Java developer has to become a Solaris admin, but it never would have happened. So they wrote Kony the Deployer. Kony the Deployer was a massive shell script, just huge. But what it did is every time the CI server finished, it deployed it to a cluster. They literally went down the hall and took some other Sun boxes and then apologized. But it put it out there and basically to a production-like environment. And so fairly quickly, once they fixed the NFS problem, deployment became a non-issue. Instead of the Friday night, get ready to camp for the weekend and so forth, it really did become a push-button thing. And I can't name the customer, but this was a massive project. It was a very important thing. And so that was really cool that it became that way, that they could deploy on demand. So from output from this, and again, these three stories are going to be fairly quick, but what did we learn, what did we do, et cetera. There's a typo in here. If you want to look for this, it's called the deployment production line, actually. Jez Humble, Dan North, and Chris Reed presented at Agile 2006 a white paper called the deployment production line, talking about doing software in this format. Jez created GoCD, not going to talk about a lot of our products, and then Jez and Dave wrote the book Continuous Delivery. So, this is one project of many that run into those, but if you've ever read that book or you've seen the concepts and so forth, this is where it came from. It came from real-world experience of not going into production-like environments on a regular basis. Okay, so Act 2, also in the UK. So this was around about 2010, and I should say, by all accounts, this project was a success. There wasn't any huge failures here, but there were still a lot of learnings. I'm a strong believer that we learn more from failure than success, but we should always look at our successes too and say, what could have we done that might have been a little bit different? So this app was a fairly typical architecture. I'm not going to go through everything, but everybody's seen that kind of thing before. And it's what we'll call today traditional continuous delivery. I mean, this was literally the year the book came out, so it wasn't traditional at the time, but what we think of today. So somebody makes a git push, or you do a git pull, and they do their code, and it does a version, stores it into an artifact repository, as it should happen. And then the next stage picks it up. Crucially, from a continuous delivery perspective, it's pulling it out of that artifact repository. Often we'll see things like, the QA build, or the staging build, or the performance build. There shouldn't be the same thing. It should be one build. The first stage builds it, puts it somewhere. Everything else uses it. So, it gets the package, deploys it to the environments, runs through all the tests, etc. If that passes, then again, goes to deploy. So this was all working very well. The actual pipeline looks something like that. I notice up here that it's still hand-rolled environments. So we weren't really doing on this project at least, real configuration management yet. They were still hand-rolling, pets and cattle that we talked about a second ago, hand-rolling these machines and setting them up, and they had monitoring and stuff on them, but they weren't being automatically deployed. Now the good, as I mentioned, this project did work. It was very reproducible. The builds were very reproducible. If there was a problem, then they would do a new commit, you get a new build, put it in the artifact repository, run through the entire pipeline, etc. Nobody was allowed to log into any of the environments. The way you fix something is by making a code change, and it goes through exactly the same thing the last thing did. So it's very reproducible. As I mentioned, we were very careful about generating the package once. That's really a very core concept. And we had a high level of automation. Not best automation, because we weren't doing the configuration management yet. And we did have that safety net. One of the things that we like to say is the purpose of a continuous delivery pipeline is to kill a release candidate. Okay, so every time you make a change, could be code, could be configuration, whatever it is, that is a release candidate. It's the purpose of the pipeline to prove it's not good enough. Okay, you can't prove something's good, you can't prove something's secure, but you can prove it's not. So this was the safety net. Now the bad is, of course, monolithic, so the entire system was deployed at once, so it took a while to deploy. It wasn't a zero downtime deployment in this case. It could have been, but it wasn't. The releases were very large, so it was deploy on demand, but they didn't deploy very often. So continuous delivery is I can deploy whenever I want. Continuous deployment is I do, just automatically, everything changes. So these were still pretty large. The browser tests were really flaky. We've all dealt with this, things like Selenium that you have to put in like implicit weights and all that kind of stuff. And I won't bad talk other people's tools, but again, we invented Selenium, so I can tell you it sucked. Yeah. I mean, the people that redid it, by the way, we invented Selenium 1. I mean, I'm not saying this about WebDriver and others, but the original, yeah. So the browser tests were really flaky. I hate flaky tests. I'd rather have no test than, it's red because that one thing's going to time out and don't worry about it. It's the broken window factor earlier. So, and rollbacks were very hard just because it was very big. So the output, what did we learn? What did we do? That some of these things you may have seen. And so I was apologizing earlier to Dan that yes, some thought workers are blamed for coming up with the word microservices. Sorry. Yeah. But Sam wrote that book. Keith wrote a book called Infrastructure as Code because we weren't doing it and we needed to. And again, these are outputs of not just our work, but lots of work across the industry. And these are the people, they would tell you they just wrote it down. But that book came out. For the flaky test stuff, we created this thing called Gauge and Tycho. Again, I'm not going to talk about our products, but these are open source. There's no commercial model, nothing. But Gauge is a testing framework, kind of Cucumber++, if you will. Tycho is a brand new, I don't know if driver is the right word, but it drives Chromium. But it drives it at the browser level, so no waits. It actually looks at a browser and it knows when the thing's up and then it'll fill the thing. So we did these kind of things to try to combat the flaky browser tests. Okay, so then Act 3. Where are we at now? What are we doing now? So this is a project, this one happens to be in the United States. And it's microservice oriented and so forth. But we've actually gone a little step further, or we're starting to go a little step further. So a microservice to us, the reason we came up with a new word, is it's a very, very specific thing. Loosely coupled, well-versioned APIs, discrete data source, can't share a data source with other things, et cetera. This one's gone a little bit further in that there's actually no direct API conversations between any of the two services. So if I need information about a customer, I write an event that says I need the customer. The customer service is subscribing to that stream. They pull up the event. They write an event that gives it back. And so it's all an event bus. So, the product domain could completely go away for a little while, and when it comes back, it'll just read the events. So trying for a little bit of resiliency there. We started to do a lot of stuff like this. The pipelines then get fairly simple, frankly. I can have a direct pipeline, so build, still might want to run some things in parallel just to speed it up. Deploy staging environments. In the modern world, a lot of times you won't have a staging environment anymore. We often do, because the purpose of a staging environment is to test a production deployment on production-like hardware. And so if you're doing continuous delivery, meaning it's on demand, you're not deploying several times a day, I need to make sure that I've run at least some tests on something that looks like production. It's also a cluster. It's also using the same kind of message queues, et cetera. And so there's still a point for staging environments. Also, a lot of our customers will actually do it like this. We're strong proponents of latest. Okay, so we're not saying take version 1.2 of service A must be deployed with service 1.3 of service B, and they deploy the staging together and make sure. In fact, if you do have that, again, we would say not a microservice, because microservices can't introduce breaking changes. But if you want to do something like this where you deploy it on together and have tests, some of our projects do this, just to ensure it. A lot of compliance stuff, sometimes they have to do a compliance check on those, et cetera. Okay, so now the details. Now, kind of the meat of the talk. I wanted to give you where it comes from, but this is where we say in modern continuous delivery is right now. Now, I'm going to show you one thing. Doesn't mean other things are invalid. Okay, so we're going to talk about some technologies, and I'm going to show you some products, or not ours, but just that we use in different places. It's not to say this is the only way we think continuous delivery is going forward, but we think this is going to be the standard for new projects, if you were starting a project today. So first off, thank you, Manuel, for saving me 5 minutes on this slide. Instead of the traditional structure, we are big proponents of products over projects, but everything he said yesterday. Okay, so they do need the proper support. It's not really everybody on all the teams. There still are services. There's still definitely platforms. We're huge fans of platforms and so forth. But organizing it this way is going to help with these smaller bits we found almost exclusively. So let's talk about the different parts of the process. So build doesn't look that much different, but almost everything is in the future, and this is not going to be surprising to everybody, it's Docker, Docker, Docker. But we can't pass these artifacts around anymore. So it used to be you'd get the jar or the war or the whatever, and you'd literally be transferring it over the wire to all the different machines and so forth. Now, we really do take advantage of artifact repositories and so forth. I'm not saying Docker Hub, not public, but setting up your own repositories and so forth. So you're not necessarily passing all the bits that you don't have to. But now what we're doing is build a unit test package, and then we're putting the package into there. I'm surprised that not a lot of people said they're using Kubernetes. And again, there are absolutely competitors to Kubernetes, but if you look at the landscape, Docker themselves is basically giving up on Swarm and has an official Kubernetes answer now. All the major cloud providers. From IBM in the private to Azure and DevOps and so forth in the public. Kubernetes is eating the world, for better or worse. But notice in the pipeline here, we're actually not passing the images along. What we're doing is things like kube control, kube cuddle, kubectl, whatever you want to say, apply. So we're applying changes that are happening in our cluster, but we're not actually passing those environments around anymore. Yep. Truck-based development. Who here is practicing continuous integration? Okay, keep your hand up. Put your hand down if you're using feature branches, if you're not going to the trunk at least once a day. Okay, put your hand down if you don't fix a broken build within 10 minutes. Those are the people doing CI. Okay, now I don't mean the entire pipeline. I don't mean the acceptance test, regression tests, et cetera. But again, the purpose of pipeline is to kill a release candidate. We're strong believers in trunk-based development, happy to argue about it in open spaces with you. But we believe it's a strong indicator. Which means that you also do need to do things like feature toggles. I purposely brought the old version. This is from a blog that Martin Fowler wrote in 2010. So the idea behind a feature toggle is if I'm going to do trunk-based development and I want trunk to always be deployable, that when I start a new feature, I need to first do a definition that turns that feature off. Then I can deploy, and that feature will be off. And it's the code's there, so it's deployed, but it's not released. Those are two different things. So deployed on the hardware, etc. Released is customers can actually use it. And this can get far more complex than that. Testing. So the good old test pyramid, fast, cheap, slow, expensive, etc. Again, thank you to yesterday's speaker for shift left, because we think that's absolutely key. So we're not saying the test pyramid goes away, we're saying it shifts left. There are still end-to-end tests. Okay, please do not write acceptance tests that are basically acceptance criteria of a user story. The user's not going to use the system that way. End-to-end tests are the way a user would use it. You're going to log in, add something to a shopping cart, what have you. Contract testing, huge. If you're going to have these distributed applications and microservice-based or whatever you want to call it, with the component tests, integration tests, we need to move those as far left as we possibly can. Then the shift right, again, repeating stuff other people have said, but from production, that's where we really need to talk about distributed tracing, fault injection, those kinds of things. There are just going to be services now. If you look at how many external APIs we use from other commercial companies or what have you, there's things that we just can't test in our pipeline. But I'll go into a little bit more. This is where canary deployments, blue-green and stuff can help keep that safe. But there are certain things that you're only going to see in production. So what about that deployment? So declarative deployments. I think it's really cool that we heard the story about Helm. We love it, we use it, but that it was too a little bit overweight, so they wrote rudder. That's awesome, but it's still declarative. So to change the way I deploy, I change a text file, not some other tool. Okay, so everything is in the source code repo, and I can rerun it at any time. So yes, YAML has its issues, as we heard yesterday. So I wouldn't put a bunch of logic in there, and choose your tool. This is not a done game. The Kubernetes one is probably kind of done for now, but this is not. But make it declarative when you're doing deployments so that other people can come in and run them and so forth. One test for this actually is if your continuous delivery or continuous integration server were completely burnt down, could you still do a deployment? Okay, so we get asked all the time, well, do you have a plugin for this or a plugin for that? Please don't use plugins, even if you're using tools that are plugin based. Don't use them. Use declarative statements and so forth so that you could deploy your system, test your system from the command line if you had to. Okay, it also keeps with vendor lock-in and a whole bunch of other stuff. So deployment strategies. Zero downtime, of course, is really important. This is going to be like really overview for a lot of people here, but hopefully there's some that this might be a little bit new to. This gives us the ability to do rolling updates, so roll it out. Depends on whether your application, whether or not that's good. But to be honest, what I really love is these kinds of things, like the blue-green. Again, not new concepts. But now with Kubernetes and with public cloud and so forth, assuming the proper billing account, which was also brought up earlier, if I have a new high-risk version, I can deploy it onto another environment in parallel, test it, just like was done at Betfair, and make sure that what I want to do and get results from it. If anybody uses GitHub, there might be one or two people here that use GitHub, they had a problem actually where the library that does the actual merges was very non-performant, the original Git library. So they needed to make something a lot faster. But merges happen a lot. So this is not something you can just play with, okay? So they wrote a new library, and for a long time, every time you did a merge on GitHub, it executed both. What was actually going into your repo was the old one, the safe one, but they were getting all the metrics from the new one and finding corner cases and finding so forth. They actually found out that there was a bug in the old one that people didn't hit very often. But if you had merge conflicts that were on a specific bit boundary, I think it was 256, so if you had 256 merge conflicts, first off, stop doing long-lived branches, but if you have 256 merge conflicts, it would say that the merge succeeded even though it didn't. So 256, 512, 768, it would tell you that the merge was successful even though it wasn't. And they found that because they had one or two that failed on the new library. But that allows you to do that without necessarily exposing the customer, and when you're ready to expose the customer, you change the load balancer, your DNS configuration, whatever it happens to be. The other big one is canary deployment. So deploying a percentage of your traffic to users and then seeing what they're doing. A lot of times when we talk about testing in production and canaries and so forth, we're talking about system health. How is the CPU utilization? What's my mem cache? What's, et cetera, et cetera. But this is a great opportunity to test how effective your business change was. Okay, if you're going to change the user path of a buying decision, roll it out to 5% of your customers and see if sales go up or down. Okay, some of the big unicorns, Amazon and stuff, they changed slightly different colors of the buy button. And believe it or not, some colors perform better. So this is a really good way to test, was the change you made effective from a business perspective? We don't see nearly enough of that in continuous delivery. We're like, oh, yep, memcache is good. Okay, but did sales go down? Then that's bad. So that's a roll back, not a roll forward. Okay, so let's do a little bit more of that. You pretty much have to do database changes out of band. This is a whole topic we can do in open space if you want, but people are like, well, if I'm going to be doing these rolling changes and stuff, so notice, we migrate database, it's version 1, then the app uses it. Migrate the database, no breaking changes, to version 2. So if you want to change name to first name, last name, you have to add first name, last name, you leave name there, eventual consistency, but you migrate the database, make sure it doesn't break V1, then you deploy V2 of the app, et cetera. So they don't get deployed together. All of this enables the dynamic environments. So we're talking about staging and prod and all that kind of stuff. These can become namespaces. So I can stand up an environment anytime I need to, for anything I need to. It's just a change to my declarative deployment. Everything's coming out of the registry, et cetera. So this gives us that elasticity to scale not only our systems, but also our pipelines. Okay, so, and again, most major CI/CD servers can do this now. Instead of eating up resources sitting there, it's basically idle. And if you want to run, like the project I'm on, we run 12,000 tests in the first phase. It takes about 6 minutes because it launches 60 machines to do it on. Because it can just stand up the environment, run the tests, get the output, shut them back down. So it gives us the ability to do massively parallel stuff. Monitoring. Fairly typical. Looking at CPU and all that kind of stuff. And this is, it's important, it's good. But we really do have to, and I know it's yet another sometimes buzzword, but there is a difference. I really would see us moving towards monitoring and observability of not only our applications, but also the pipelines. Okay, now as was mentioned, don't alert on your staging server, please. Okay, but if you have observability of your pipelines and your application, you can start to see things happening before they get to production. You can start to see trends that we're working on this new feature and performance is degrading. Okay, there's lots of things you can do if you look at really getting events in there a lot. If you look at honeycomb.io, there's one of the vendors in it, but they've got a bunch of really good blogs. Look at any talk by charity majors if you want to learn more about observability. But I think this is going to be really, really important. Security. Where does security fit? Okay, so we always say shift left and put it in build or what have you. Nope. And now it really does have to become everyone's job. Now, I don't mean that everybody has to become a security tester, okay? This is a skill set, like a lot of skill sets. And I know that really deep knowledge people aren't available to put on every product team, but we have to be thinking about this all the way through. And there's ways to do it. So from a vulnerability plan, again, I have no relationship with these, but there's things like Sneak, where I can do basic CVE scans of my images. So for years, we've had tools to do like Breakman for Ruby, so I can say, oh, that you got a CVE on that gem. The folks that run Maven Central, blanking on their name, Sonatype, did a study, and they found that more than 20% of the packages being used on the open source Maven stuff had known critical CVEs. But the version numbers were hard-coded in the POM files, and so they'd still been checking them out, even though they'd been fixed in later releases, et cetera. So we need to be scanning those things. When we're going to container-based, there are lots of tools for that. Sneak's a good one. Going to CVE scan, in the images. Twistlock is really interesting because this there's a lot of tools like this for on metal, but basically what it's looking at the runtime of the containers, and it says, hey, normally your app doesn't touch that directory, but today it did. So there might be something weird going on there. You might want to take a look at that. And a whole bunch of other stuff. But again, there's good tools for these things. Secrets management, something I suck at. This is another thing for cross-functional teams. Our technical director gave me this slide. Do it, that's all I know. Yeah. But I mean, seriously, things like Vault, etc. Please don't put your secrets in Git. Please don't put them in your containers. So the epilogue. Where are we going in the future? I really do think that teams have to be structured. Your organization has to be structured to own small pieces. Our CTO says if you don't like how your applications look, then change your organization. But again, I love the team topology stuff. If you haven't read Manuel and Matthew's book, please do, because these teams need support, okay? But things do have to be in small pieces. You know, consultant, easy for me to say this, but right now, Docker and Kubernetes are eating the world. I'm not saying convert your legacy apps to Docker because you can. Okay, the other word for legacy is the stuff that makes our money. But if you're doing something new, this is where we're at today. You got to test in production now. If you're going to do distributed things, there's just no way to know what's happening without you do it. Own it and architect for it. So make sure you're getting the traceability you want. Make sure you have contract testing. Make sure you have those kinds of things. Security is everybody's job. There's the camera screen. Because I didn't really make up all this. So as was mentioned yesterday, citing your sources is important. But you can learn a lot more from there. And again, I'm already over time, but I'll be around all day to answer questions and so forth. All right, cool. And that's it. Thank you. Lunchtime.
Thank you, Ken. Time for 2 questions. Yeah.
Okay.
Hi. About declarative management, one of the challenges we have is about rollback and configurations. You mentioned to not use any plugins or things that could make a locking. Do you have any strategies to apply patches on declarative management?
I'm sorry, I didn't catch the last part of the question.
So the declarative management you just said about, one of the challenges is about the rollback configurations, mostly because you have YAML files and lists. You need to patch the things to go back previously. The managed strategy is pretty tricky. You mentioned not to use any plugins or try not to not have locking. Do you have any strategies to manage this kind of rollback and declarative management?
So generally, especially with these newer architectures, we avoid rollback like the plague if at all possible, meaning we roll forward. Okay, so if we're making a configuration management change, if we're changing a chef recipe, a Docker file, or what have you, it's going to go through the exact same pipeline that everything else does. And so if there's a change in there where like I change a library in a config management and now my unit tests fail, the fix is to make a code change that rolls it forward. Update the library, delete the lines I didn't do a do commit, etc., so that the pipeline goes again. What you really want is you want the pipeline to run through everything on all of your different environments. Okay, so whether it be a Helm chart or whatever it is, that needs to go through from the very beginning all the way to the end, so that you're not in a production thing where, oh, we changed configuration in production, but now it doesn't look like those other ones, hence immutable servers too, throwing them away, etc. But it's really about roll forward.
So basically, do not apply the previously version, just patch on top of that.
I wouldn't do it as a patch. I would do it as an actual change of the configuration file and run it through your pipeline.
Okay.
Yeah. In fact, there's a blog on gocd.org where if you were to download GoCD, which is an on-prem thing, the pipeline for GoCD is very, very long. But there's a short circuit in there where if there is like a security problem or something like that, the PM can take, as soon as they get an installer, he can hit a button, or our MD, she can hit a button that goes right to production. And now then the other tests run in a trailing factor. But I can skip the long-running tests in an emergency. But I'm still going to run all the other ones so that I know if anything came up, so I can, again, make an adjustment if I need to.
Okay, thank you.
Yeah.
Okay.
Sorry, we're all ready for lunch. Just a quick question. You mentioned security tests in the pipeline.
Yep.
How early, late, or whenever do you think is the best time to run them?
The very, very beginning. So the project I'm on, when you do a commit, it runs multiple pipelines in parallel. So it starts doing unit and functional tests on Linux, Windows, and a security pipeline kicks off at the same time. That's doing basic like CVE scanning and so forth. It's not really deep, but it's at least saying, okay, wait, no, you would check in a secret. We actually wrote, and again, it's an open source tool called Talisman, which you can find on GitHub. That's even a pre-commit hook. So you put Talisman on your dev machine, and when you do a commit, if it sees something that looks like a secret, won't let you do the commit.
Thank you.
Yep.
Okay.
Thank you.
Thank you.